Welcome to the project demonstration of solar dual axis solar tracker along with UPSC. So in this one we are going to control the direction of this solar panel in two directions, dual axis. So one is east to west, another is whenever the wind in winter seasons, as we know, the sun is deviate from the east to south side. So that will be detected by the another two LDR sensors. So two LDR sensor for east to west, and these two LDR sensor to detect the deviation of the sun from east to south side. So based on that, we are going to control the direction of this solar panel using the two DC motors. One DC motor to control the east to west, another DC motor was placed under this whole setup. This will be controlled with the help of the other DC motor. With these two DC motors attached to the PIC 16F72 microcontroller through the L293D motor driver. So L293D motor driver can control the two DC motors in bidirectional. And we have interfaced these four LDR sensors at A0, A1, A2, A3 pins, and the L293D motor driver at C0, C1, C2, C3 pins, and the whole system driven by the 12 volts 2 amps battery. So as we can see, this is consists of two battery packs. Each battery pack has the 3 4 volt 1 amp batteries are connected in series, and these two are connected in parallel, so we will get 12 volts 2 amps. So this can be recharged with the help of solar panel as well as from the grid. Whenever the sunlight is not available, we can recharge that by using the transformer. And also we place the three limit switches, one limit switch for the east end, another limit switch for the west end. So these are used to set the limit for the rotation of this solar panel. So as you can see that this is one more west side and the east side, one more for north south side limit switch. So these three interface at C5, C6, C7 pin off or same PIC microcontroller, and we are providing 12 volts inputs to the motherboard. So there we have the 7805 regulator on this motherboard, so which is used to regulate the voltage from 12 volts to 5 volts. So once it get the 5 volts power supply, it start reading input from the initially limit switches as well as LDR sensors. So next, coming to the inverter UPS. So here we have the 50 hertz 12 volts to 230 volts AC step up converter, so which is mainly purpose is DC to AC converter. So on this one, so one is a 7805 regulator which is used to provide the USB power supply for mobile phone charging purpose, and the next these two MOSFETs are used to convert the 12 volts DC to 12 volts pulsating DC, nothing but AC signal with help of this controller. So the controller will generate the 50 Hz pulses, and that was given to the MOSFET trigger gates, and then the MOSFET will provide us the 12 volts AC signals, and with help of this step up transformer we are going to convert the 12 volts AC to 230 volts AC signal directly, and that was can be retrieved from this load section as well as the 3-pin socket. Right, actually we need to on the whole system power supply by using this switch. Okay, when we switch on this switch, the solar panel rotates to initial position by the two sections. One is the east to west, and there is the south end section one. This is the inverter mode. And coming to the solar panel, so when we want to charge a battery from the transformer, just connect the transformer at this section, or else if you want to charge the panels or battery, so using the solar panels, just disconnecting the transformer and connect the solar panel over here. So if you charge a battery with the help of transformer or solar panel, it will be fully charged in a duration of 8 to 10 hours, and then after automatically the current will be stops using these two diodes, and remaining 3-4 diodes are used to convert the AC to DC when we providing the input of AC signal, and polarity corrector when we providing the DC power source input, as we can see the light indication over here. Right, so let us see demonstration. So already the solar panel was set to 0. Right, so So when the sun is moving, the sunlight is falling on the two LERs. So whenever the back end LER getting low voltage and the front end LER getting more voltage, then the microcontroller take a decision to rotate the DC motor and check with again sunlight intensity. I should what is called light. So when that solar panel touches the west side limit switch, as it indicated, the sun sets, and then automatically two motors will set to initial position, back to the 0. Right. Right. So again, it will go with the wait for the sun again in the morning, start rotating based on the sun position.